Hi, welcome back to another high school chemistry video. You're going to be talking about isotopes today. So just to review real quick, we have the atomic particles, we have the electron with a charge of -1, mass of 9.109 times 10 to the negative 31st kilograms. It's in the electron cloud. Today we're mostly going to talk about the particles that are in the nucleus. We have the proton, which has a +1 charge, has its mass in kilograms, and it's in the nucleus. And then we have the neutron, which has a similar mass to the proton, as well as 0 charge. So the proton is what determines what element we're talking about. Which element it is has to do with how many protons. So again, we have the nucleus is the tiny, tiny speck in the middle where the protons and neutrons are. Electron cloud is where the electrons are around the outside. Most of the mass of the atom is in the nucleus where the protons and neutrons are. The electrons are, again, outside. Most of the volume of the atom is empty space. Isotopes are atoms of the same element having different masses due to varying numbers of neutrons. So the identity of an element is based on the protons. So all hydrogen atoms will have 1 proton. To balance that charge, they must also have 1 electron, assuming they're not an ion of some sort. But hydrogen 1, called protium, has 0 neutrons. Hydrogen 2, also known as deuterium, has 1 neutron. Its nucleus looks like this. And then hydrogen 3, or tritium, has 2 neutrons and 1 proton. Those names, of course, come from the masses, right? So the deuterium has twice the mass of protium. Tritium has 3 times the mass of protium. So atomic mass is the average of all the naturally occurring isotopes of the element. So you take the mass of each element, you multiply it times its percent abundance in nature, and then add all of those up. So for carbon, we have carbon 12, carbon 13, and carbon 14. You'll notice that most carbon is carbon 12, 98.89%. Carbon 13 is about 1.11%, and carbon 14 is less than 0.1%. So you multiply the mass, which is 12, 13, and 14, times the percent abundance, and then add those up to get your carbon average mass, which is 12.011. The atomic number of an element, or Z, is the number of protons in the nucleus of each atom of that element. So for example, carbon has 6 protons. It has an atomic number of 6. Phosphorus has 15 protons, has an atomic number of 15. Gold has 79 protons and an atomic number of 79. The mass number is the number of protons and neutrons in the nucleus of any given isotope. So mass number is equal to protons plus neutrons. For example, we have oxygen that has 10 neutrons. You can look on the periodic table and see that it has 8 protons. So this oxygen with 8 protons, 10 neutrons, is going to have 8 electrons to balance the charge of that proton. It's going to have a mass number of 18, which means we're going to call it oxygen 18. So moving from here, we have arsenic. We know it's arsenic because the protons are 33, which means the atomic number is 33, which means we can look that up on the periodic table and see that it's arsenic. We know that there are 33 electrons because there are 33 protons. It tells us the neutrons is 42. Mass number, add up 33 and 42, you get a mass number of 75, so we call that arsenic 75. We have protons at 15. We have a mass number of 31, so that's phosphorus 31 because it has an atomic number, same as the number of protons, of 15. You can then subtract 15 from 31 to calculate the number of neutrons. It has to have 15 electrons to balance that charge. So 31 minus 15 is 16 neutrons. Here's some definitions that are useful. Isotopic mass is the average mass of the atoms of a specific isotope of an element. This is what you see from the periodic table, is the isotopic mass, or the average mass. The isotopic abundance is what percent of the element's atoms are a specific isotope. So again, it's that 98% or so of carbon-12 is the isotopic abundance of the carbon-12 isotope. Atomic mass is the average mass of an element's